Have you ever stopped to think that the most desired and closely guarded object on Earth isn't actually made of paper? What you have in your wallet right now is, in fact, one of the most sophisticated marvels of molecular engineering and national security. While the world sleeps, inside armored facilities in Washington, D.C. and Fort Worth, Texas, a silent symphony of titanium and lasers works to print what sustains entire civilizations. We are entering the heart of the BEP, the Bureau of Engraving and Printing. Forget everything you know about ordinary print shops. Here, precision is not measured in millimeters, but in microns. A single deviation in ink density or fiber texture can trigger a national security alert. We are talking about an industrial warfare operation that moves hundreds of billions of dollars every year, where no error is tolerated and no human touches the final product without robotic supervision. But how do you transform raw bales of plant fibers into the most secure and influential currency on the planet? Get ready, because what you are about to see today is the complete process, from the first thread of cotton to the fortified vault. The journey of the dollar begins far from the printing presses, in agricultural fields selected under strict confidentiality contracts. Unlike any book or magazine, the American dollar is composed of an exact mixture of 75% cotton and 25% linen. This is not an aesthetic choice. It is a decision for survival. This combination creates an ultra-resistant textile fiber that allows a bill to be folded more than 4,000 times before tearing. If you tried to print dollars on ordinary paper, they would dissolve in the first accidental wash. Here, the raw material arrives in massive bales, which are shredded in giant industrial mixers to form a dense pulp. It is at this stage, before the sheet even exists, that the first secret is inserted: the 3D security ribbon. White robotic arms, operating in a dance of absolute precision, insert thin polymer strips into the liquid mass. These strips are not glued. They are fused into the molecular structure of the bill, making it impossible to remove them without destroying the money. Technicians in vibrant yellow protective suits monitor the viscosity of this pulp through ultrasonic sensors. They look like astronauts in a NASA laboratory, but their mission is to ensure that the foundation of the dollar is imperishable. When the pulp is pressed and dried by rollers heated to exact temperatures, the result is a roll of currency paper that is born with watermarks and internal security threads, ready to receive the soul of the empire. With the base sheets ready, we enter the printing wing, where mechanical engineering reaches its climax. The American dollar does not use conventional inkjet or laser printers. It utilizes the Intaglio process, or calcographic printing. Imagine solid steel plates, hand-engraved by master craftsmen over months, where every line of Benjamin Franklin's or Abraham Lincoln's face is carved with the depth of a human hair. These plates are mounted on rotary presses that exert a brutal pressure of 20 tons per square inch. This pressure is so intense that the paper is literally forced into the grooves of the plate, creating the tactile relief you feel when you run your finger over the bill. It is this controlled deformation of the fiber that gives the dollar its characteristic snap sound when stretched. Rivers of green and black ink, manufactured in secret laboratories with formulas that include magnetic polymers, flow through stainless steel pipes. Autonomous white transport robots move stacks of sheets worth millions of dollars from one station to another without any human intervention. Each sheet contains 32 notes and passes through high-speed optical sensors that take photos of every square centimeter, comparing the result with a perfect digital model managed by artificial intelligence. If a single drop of ink is out of place by a tenth of a millimeter, the sheet is marked by an infrared laser for immediate destruction. Technicians in their yellow suits perform random checks under electron microscopes to validate the ink crystallization. Dollar ink needs to dry in a specific way so that the optical properties change color as you tilt the bill. In the stage of the $100 bill, the iconic bell in the inkwell utilizes micro-mirror technology. Thousands of tiny glass lenses, invisible to the naked eye, are deposited over the ink to create the illusion of movement. It is the meeting of Renaissance art with quantum physics. After the face printing, the sheets enter the overprinting and serialization phase. This is where each bill gains its unique identity. High-cadence pneumatic presses fire the serial numbers in magnetic green ink. The pace is local. Machines process 10 sheets per second. Every movement is monitored by line scan cameras that detect registration errors in real time. But the most visually satisfying part happens in the cutting wing. Imagine industrial guillotines equipped with hardened steel blades that never lose their edge. The stacks of sheets are aligned by robotic arms using vacuum suction cups to ensure there is not a single millimeter of square error. When the blade descends, it cuts through thousands of dollars with the ease of a hot knife through butter. The sound of the cut is a metallic percussive that echoes through the factory. At this point, what were just large sheets are transformed into perfect blocks of individual notes. Stacking robots organize these blocks into bundles of 4,000 notes, known as bricks. Each brick is wrapped in a heat-shrink plastic film that shines under the factory's white LED lights. It is at this moment that security logistics reach the maximum level. Each package receives a tracking barcode that is linked to the Federal Reserve's central system. If a package goes missing from the line, the system automatically locks down the entire wing and the armored steel doors close in milliseconds. The workers in yellow suits monitor everything from a control room that looks like the launch command for a SpaceX rocket. They are not just watching the money, they are guarding the integrity of the world's economic system. Each white robot moving across the factory floor is equipped with state-of-the-art LiDAR sensors to avoid collisions and ensure the production flow never stops. If the flow stops, the operational loss is millions of dollars per hour. Before they go out into the world, the notes pass through one last court, the stress laboratory. Samples from each batch are subjected to brutal tests. They are boiled in chemicals, washed in industrial machines with abrasive stones, and exposed to extreme ultraviolet radiation. If the industrial chocolate from our last series needed perfect tempering, the dollar needs invulnerability. The note must maintain its integrity and color even under extreme conditions. Meanwhile, the rest of the production moves to the final packaging area, where lights-out logistics comes into play. In an immense and silent warehouse where lights are kept off to save energy, hundreds of white AGV robots glide in total darkness. They are guided by invisible magnetic tracks on the polished floor, moving pallets loaded with billions of dollars. Security is so absolute that even the air is monitored. Particle sensors detect any attempt at drilling through walls or the ceiling. When the armored trucks arrive at the loading docks, the process is a military operation. Workers in yellow suits and white helmets coordinate with armed agents to load the pallets. Each pallet is sealed with electronic seals that emit encrypted GPS signals. The destination? The 12 regional Federal Reserve banks scattered across the United States. From there, the money you saw born as a mixture of cotton and linen will be distributed to the rest of the planet. At the end of this journey, it is clear that the dollar is not just a piece of material. It is the result of an obsessive fusion between industrial brute force, high-precision chemistry, and a robotic network that never sleeps. Mission accomplished. Another batch of billions of units is ready to fuel the global economy. We have reached the end of our journey inside one of the most secret and powerful facilities in the world. We have seen how technology has transformed the act of printing money into a science of surgical precision, where robots and humans in protective suits work in millimeter harmony. The manufacturing of each bill that passes through your hands is a testament to the power of modern engineering and the human obsession with security. But the game never stops. While you watch this video, engineers and scientists are already developing the next generation of conductive inks and polymeric substrates that could transform dollar bills into smart devices. The future of money may be digital, but as long as physical currency exists, it will be produced in this fortress of steel and glass, protected by lasers and brilliant minds. And now, I want to hear from you. After seeing this entire technological process, the precision of the robots, and the almost space-like rigor of the laboratories, can you still look at a simple dollar bill the same way? What surprised you the most? The security thread fused into the pulp or the presses that apply 20 tons of force? Leave your opinion here in the comments. If you are fascinated by mega factories, heavy engineering, and the secrets behind the objects that move the world, don't forget to subscribe to the channel. Every week, we open doors that the general public would never cross. Turn on the bell so you don't miss our next industrial exploration, where we will enter another empire of steel and technology. Thank you for staying with us until here. May curiosity continue to move your world.